All right, so this I would argue is the hardest question that we will see in this, maybe this unit. So this is a tricky one. So the ski guy, he's going to go off of the ski and he's going to land down here at some place. So this is actually more, it's not a inclined plane problem as much as it is it's a projectile motion problem. Okay, so let's talk this through. Took me a while to think this one through, but what do I know about, well, let's write down. I know x1 is 0. x2, we don't know, okay? v1x, we know to be 16 meters per second, okay? We also don't know v2x, and I don't think we will need to know that. We don't know time. Number of things we don't know. We do know the acceleration. In the x direction, acceleration is 0. He's not accelerating in the x direction. He's only accelerating in the y direction. So let's write down my y's. I got y1. Now, this is an interesting question. What I'm going to probably break a rule at some level, but I think it works out better. I'm going to say y1 is 0. So I'm going to say that this is 0, and we're going below. And then y2 will be some negative answer, but we don't know what that is either, okay? Because it's going to fall, right? We know what's v1y. Now, a lot of people think, I don't know that. Yes, you do. It's 0 because it's not. He's moving horizontally when he goes off the jump. All right. We don't know v2y, but I don't think we're going to need to know that. That's not. We're trying to solve for time. Time, well, that's our question mark. But we do know the acceleration. It's negative 9.8 meters per second squared, right? So we know all of these numbers, and now we want to solve for time. So the first thing I did is I wanted to say, what is y2? So I can use the equation y2 equals y1 plus v1yt plus 1/2 at squared, right? So y1 is 0, so I can just say y2 equals 0 plus 0. Now, I do know what 1/2 of a is, so I'll say plus negative 4.9 t squared, or I can just say y2 equals negative 4.9 t squared. Now, I've got a y2 and I've got a t, so I got a problem, okay, but that's one part. So we've got that. Next, let's play with the x's. What do I know about the x's? I can use the same equation, if you will, but the x's. I can say x2 equals x1 plus v1xt plus 1/2 at squared. Now, x2 is how far he's going to travel across here, but x1 is 0, so I can say 0. Now, let's actually talk about this x2. This is where the trick is on the x2. Well, let's just keep going. Plus, but I do know this is 16t plus 0. So I can say x2 equals 16t plus 0. But x2, all right, I need to zoom in or something like this. Because we have a 45-degree angle, right? Because he's going to fall, when he lands, he's going to land somewhere down here. So let's do it right here. So when he lands, this is x2, and this is y2, correct? And we know this angle is 45 degrees. So I can solve for x2 in terms of y2, if that makes sense, or vice versa. And so I can say tan 45, this is 45, is equal to y2 over x2. Does that make sense? And so then what I did is I then said x2, I think this through. I said x2 is equal to y2 over tan 45. All right, so if I know that, if that's x2, I can now plug this in here. I can say x2, take this here, I can say y2 over tan 45 equals 16t. But what is y2? I know that from here. So I can say negative 4.9t squared over tan 45 equals 16t. And I do believe I've got a sign issue here. I do. Now, one thing that I discovered, I plugged this into my solver, is that when I did the problem and solved for it, the y2 is going to be negative. So it's actually technically -1. So what you're going to do is you're going to make this positive, because this becomes, it's the negative y2 is negative 4.9t squared. And so to make what y2 is, this becomes y2 is equal to 4.9t squared. Yeah, that's how it does it. And now, at this point, we now have just t, and by itself, if you will, it's a quadratic ball game, but you can solve this problem using a solver or some other method, and you should get the answer. That's a tricky question.